are picking up in, what is this, 1.6, where we left off yesterday. We were just starting to talk about our stretches and shrinks. And we looked at example A. And if you recall, in example A, it was a number value multiplied by x squared. And when we look at the front of our notes, the page shows that if it's a number multiplied out front, it's a vertical stretch or shrink. Number 2 is bigger than 1, so it's a vertical stretch. Okay. B. Thoughts on B?
It's a fraction.
It is a fraction. Okay. Okay. And here's, I'm going to be honest, this one's we could go 2 different directions with this one. Okay. The design of this one is we do want to talk about the horizontal relationship. Okay. So let's talk about this decimal 0.4. What do you know about the decimal 0.4? It is 4/10, which reduces to 2/5, yes? Okay. Now, okay, here's the deal. Right now then, this y equals 0.4x quantity squared. This is then, if we think fraction, is y equals 2/5 x quantity squared. Now, here's the slight catch. In order for it to be horizontal, which is what I want to talk about, if you go back to the horizontal part, what is that, 2 slides back? Horizontal is x divided by c. So it's the value divided by c. Whereas technically, what do we have right now? We have it times, right? We have 2/5 times x quantity squared. Okay.
So it would be x over number 1.
Well, we're going to take, okay, so right now, think of it as 2/5 times x, right? So I'm going to do a side note. I'm going to erase this right now. It is 2/5 times x. We can also think of this as x times 2/5. I'm writing it like that on purpose. What do you know about division when fractions are involved? Okay. Which phrase did you use?
Keep it, switch it, flip it.
Keep it, switch it, flip it? Okay. And there's all different ones. That's why, you know. There's all different ones you guys learned when you guys were learning dividing fractions, okay? So, with that in mind, if this was division, this would have been x divided by 5/2. Can I sell that to you? Because x divided by 5/2, if you're changing division to multiplication, would be x multiplied by 2/5. So what I'm trying to say is that 2/5 times x is the same as x divided by 5/2. So I'm going to rewrite this as x divided by 5/2 quantity squared. Now, based on this form, we can now talk horizontal. Because you've got the x divided by a value. What is this?
Shrink.
Why?
Because the original was 2/5.
The original was 2/5, but what is it right now?
A stretch.
Okay. So, well, yes, when it was multiplied by 2/5, 2/5 was less than 1. But here's the deal. This is x divided by 5/2. What do you know about 5/2? That is a number bigger than 1. So that's going to make it a horizontal stretch. Okay, so this is now, leave a little room at the bottom if you still have it, because we're going to talk about what else this could be. Horizontal stretch officially by a factor of 5/2. I just don't have a ton of room. Now, let's talk or. Okay. 0.4x quantity squared. If we applied that squared, how would this be written? Does that make sense what I'm asking?
X would still be.
Okay, it'd still be x squared, right? But what would have to happen to the 0.4? Like if this square applies to both pieces, you would have to also square the 4/10. And what is 0.4 times 0.4? 0.16. So this could also be written as 0.16x squared. If we write it as 0.16x squared, we now have a number times x squared, yes? What would you call this then, if we're just looking at the 0.16x squared? A number multiplied by x squared is going to make it vertical. Stretch or shrink?
Shrink.
0.16 is less than 1, isn't it? So this could also be considered a vertical shrink by 1600. Okay? That's an either or type thing.
Would either one be right on the test?
Yes. Yes, either one would be right. Now, we just gave two totally different answers. Do they correlate? Think about this.
Yeah.
Horizontal stretch. What's a horizontal stretch going to do? Horizontally, so left to right, it's going to make it wider. What's a vertical shrink going to do? Vertically, it's going to push it down, squish it down. As you squish something down, what happens? It gets wider. Okay, so there is a direct correlation between horizontal stretch and vertical shrink. Okay, so the design of this problem, because this was in parentheses and not squared yet, the design was to get you thinking about horizontal. Okay, however, there is a vertical component as well. On example A, it was just 2 times x squared, so that was just definitely a vertical one. We didn't really have the horizontal to think about there. Okay, so let's try and talk our way through C then. C is y equals 5x quantity squared.
Well, couldn't it just be the same thing that we just did?
Yes. I'm not sure which way you're asking about that, but what are my options here?
25x squared.
Okay. Could we say, and I'll go ahead and put this at the bottom, that 5x quantity squared is the same thing as 25x squared? And if we look at it as a 25x squared, what is that? It's a number multiplied by x squared, so it's vertical. 25 is a number bigger than 1, so that makes it a stretch. So this could be considered a vertical stretch. And officially you should say by factor of 25. I'm shortcutting here because I have limited space and I can't write this small as I can with pencil. Okay? Yes?
So would the vertical stretch correlate with the horizontal shrink? Like the horizontal stretch correlates with the vertical shrink?
Yep. So let's look at this. This currently is 5 times x, right? Multiplying by 5 is the same as dividing by the reciprocal of 5, which is 1 over 5 or 1/5. So I can rewrite this as x divided by 1/5 quantity squared.
So then horizontal shrink.
Right.
1/5.
Yeah. Okay, so multiply by 5 is dividing by 1/5. Because it's dividing the x within the square, it is horizontal. 1/5 is less than 1, so this is a horizontal shrink by a factor of 1/5.
So could the first one be a horizontal shrink? Like
Yes. A would have a horizontal shrink with it as well. It would just be harder to find by what factor. Okay. Because it would have to involve like, what, 1 over square root of 2? It's not already in that parentheses, so. Okay, D. What am I looking for on D, you think? Y equals 1/3 x squared. There's no parentheses. Go straight for it, plain and simple.
Horizontal stretch. Or do I have to flip it the other way?
I'll just go vertical stretch.
There would be some kind of horizontal stretch there, but by what factor would be harder to find. Kind of like on A. When it's just a number multiplied by x, you're going to be easier off going with a vertical movement.
Shrink.
Okay, so I would suggest vertical by a factor of 1/3, which makes it a vertical shrink. So vertical shrink by a factor of 1/3. Okay. So on homework, if it's an either or situation, I'd prefer you try and look at the horizontal option, but I don't remember. I probably have both on the answer key would be my guess. Okay. Okay. Let's look at example 5. We're going to write some equations with horizontal and vertical shrinks and stretches. Okay. So kind of here we're looking at the equations, determining what they were. Now we're going to do the opposite. So let the function be defined by f of x equals x cubed minus 16x. There's your given function. Find the equations for the following non-rigid transformations of f of x. So, vertical stretch by a factor of 3. How do we do a vertical stretch by a factor of 3? Okay, or in other words, we're going to multiply by 3, yes? The short of it is, in order to do a vertical stretch, you're going to multiply by 3. Like if you go back and look at the chart on the front, you'd be doing 3 times f of x, right? It says c times f of x. Now, what's that mean we're going to do here? We're going to be multiplying not just the x, but everything by 3. So in this case, you're going to be multiplying x cubed minus 16x all by 3. Okay, because on a vertical situation, you're multiplying the whole function. Okay, so if we do that and we clean it up, take that 3 and distribute. 3 times x cubed is 3x cubed minus 3 times 16x is 48x. And that would represent a vertical stretch by a factor of 3 on that equation. Okay. B. A horizontal shrink by a factor of 1/2. So go back to that first page. How am I going to show a horizontal shrink? We're looking at that form right there, yes? F of x divided by c. So I'm going to think of this as f of x divided by what? 1/2. Because it asked me to do a horizontal shrink by a factor of 1/2. So that means it's going to be x divided by 1/2. Now, do you want to take this equation and every place you see an x, plug in x divided by 1/2? I'm not sure I really do. That sounds kind of ugly. But what do we know about x dividing by 1/2? What is that the same as? Multiplying by 2, yes. Because dividing fractions is the same as multiplying by the reciprocal. So x dividing by 1/2 is the same thing as multiplying by 2/1. Well, 2/1 is 2, right? And 2 times x is 2x. So I can instead of thinking about this as f of x divided by 1/2, I can think of this as f of 2x. And now with f of 2x, that's an easier one to process. Every place I see an x, I'm replacing with 2x. So it's supposed to be x cubed. What am I going to do instead of x cubed? Instead of x to the third, it's going to be 2x to the third. Notice I use parentheses. Minus 16x. Instead of minus 16 times x, it's going to be minus 16 times 2x. Every place I see an x, I'm using 2x instead. And then other than that, it's cleanup. What do you know about 2x raised to the power of 3?
2x raised to the power of 3.
Not 2x to the third. The 2 is in the parentheses, so 8x to the third. Because 2 times 2 is 4, times 2 is 8. Minus 16 times 2x is 32x. Okay. So the vertical stuff is easier to work with all the way around. That's all there is to it, okay? Vertical or horizontal stuff takes a little bit of work, but it is doable. Okay. Got a little bit of an idea of what you're doing with the stretches and shrinks? Or whatever, stretches and compressions. Look at example 6. Combining transformations in order. Okay, so this is taking multiple transformations and putting them in the proper order on the equation. The graph of y equals x squared undergoes the following transformations in order. Find the equation of the graph that results. So we have 3 pieces here. We're going to take this x squared, we're going to shift it to right, we're going to stretch it by 3, and then we're going to translate it 5 up. So, here's my suggestion. Let's go piece by piece. What is my equation of y equals x squared look like after I have the graph shifted 2 to the right?
Minus 2 parentheses.
So how does that read with my x squared?
Parentheses x squared minus 2 parentheses.
Partially right. You said parenthesis, x squared minus 2 parenthesis. There's something I'm not happy with the placement of.
The squared is outside the parentheses.
Right? Because it's left to right. That minus 2. Okay, so 2 right is demonstrated by a minus 2, right? The minus 2 is in the parentheses. Now, when we write this, x minus 2 in the parentheses, the function or whatever it is outside of that. So this was squared, so it's outside. So that right there is saying the quadratic graph shifted 2 right. Okay? Now, what about if I add in a vertical stretch by a factor of 3?
Are we adding all the first?
Right. So we're taking what we already have, the x minus 2 squared, and now we're going to stretch that by a factor of 3.
Would it be 3 and then the parentheses?
Mm-hmm. So 3 parentheses x minus 2 squared. Okay. And because it's x minus 2 squared, it's not something you distribute in or anything. It just stays out front. And then a vertical translation 5 up. What's that going to look like?
Just add 5 to the
Okay. Vertical one is add or subtract at the end. So we're going to add 5 at the end. So 3 times x minus 2 squared plus 5. Okay. Now, B. What's B asked me to do?
Do
Reverse the order. Okay. So B, we're going to reverse the order. We'll start with the 5 up. Now, and we're going back to the original. So if it's y equals x squared and we start with the 5 up, what's that going to be?
plus 5.
Okay, y equals x squared plus 5. Then, vertical stretch by a factor of 3.
3x squared plus 5.
What'd you say?
3x squared plus 5.
Maybe. Except that this vertical stretch is on the whole thing. So I'm going to take my x squared plus 5 and put it in parentheses. So y equals 3 times x squared plus 5. Because it makes a difference of whether you stretch it before you move it. Okay, that definitely makes a difference. And then the last part, what am I doing? How do I do 2 right?
Just x minus 3.
Okay, you've still got to take that to go 2 right. You still got to take that minus 2 and put it in with the x. Now, the key is we still have that 3 outside, right? And then it's parentheses that's already there. And then we're going to do parentheses for the x minus 2. We're going to square that, plus 5, and then in my other parenthesis. Okay? The big difference here is that this stretch of 3 is after the plus 5. Okay, so that affects the plus 5. That's the big difference. So notice, same operations, different order. Notice my answers are written in a different order. So just beware. Okay, example 7. I redid the notes this year, so we'll see. Same example, I just put it in differently. We'll see how this works. The graph of y equals f of x is shown. Determine the graph of the function y equals 2 f of x plus 1 minus 3 by showing the effect of a sequence of transformations on the graph of y equals f of x. So f of x is this graph right here. Okay, that's f of x. This is the equation we're going to graph, but we're going to graph it in pieces. Okay? As we graph it in pieces, well, let's talk about what are the different transformations we're going to have to do.
Left 1.
Okay?
Stretch it 2.
So there's going to be a left 1 at some point. There's going to be a down 3 at some point and a a vertical stretch by a factor of 2 at some point. Yes? Those are all the pieces. Now, order. Okay? There's some flexibility, but there's also some right or wrong. I like to think of this, what I want to compare it to. Like when you're trying to do order of operations or something. Okay? You want to start in closest with the x. Okay? So if we're starting in closest with the x, what would that indicate my first transformation is going to be? The left one. Okay? So we're going to, and I'm just going to we're going to do the x plus 1 here, or in other words, we're doing the left one on this first graph. Now, there's basically 4 tick marks on each piece, yes, on each section of the axis. If we're going left 1, actually I didn't need that extra, did I? Okay, so kind of look for pieces here. There's an intersect at -2, 0, yes? Where's that going to be? At -3, 0 now. My graph went up as high as 0, 2 on the y-axis. Where's that point going to be at now? Yeah, -1, 2. And then it did end at 4, 0. Where's it going to end now? 3, 0. And notice you've got a little like piece of a circle, and then it looks like a piece of a triangle. Mine's not the greatest, but okay. What do you think needs done next?
Down to
Nope.
stretch 2.
Stretch 2. And here's the deal. Work closest to the x. The left one was on the inside there. Then you've got the times 2. Okay? So we are going to think next about the 2 times f of x, which is our vertical stretch by a factor of 2. Now, I will throw in these first 2 here, these 2 right here, the left one and the vertical stretch, because they're both right there on the f of x, they could be reversed, and you'd still get the same result in the end. Okay, so I'm going to throw that in there, that these 2 could be reversed, and you would still be okay. Now, let's see, I still need, I think we'll still be okay if you just do 4 tick marks. Okay, do you remember how to do a vertical stretch? Vertical affects which values? X or Y?
Y.
It's your Y values, right? A vertical stretch by a factor of 2, you take every Y value and multiply it by 2. So, look at the points we just had. For instance, I was right here at -3, 0. What's the Y value in -3, 0?
2.
No. What's the Y value in -3, 0?
Oh, 0.
0. What is 0 times 2?
2.
0. So this point is actually going to stay the same. When something's on the x-axis, it's not going to actually stretch up. It's going to be the rest of the graph that stretches up. Okay. This point had moved 1 left and was up 2, yes? 1 left, up 2. When I vertically stretch that by a factor of 2, what's my Y value? It's left 1, up 2, so 2 is my Y value. What happens when I stretch that by a factor of 2? 2 times 2 is 4. So instead of going left 1 up 2, it's going to be left 1 up 4. The other point we were at was 3, 0. What is the y value there? 0. And 2 times 0 is 0. So that's just going to stay at 3, 0. Take all your y values and multiply. So all this does is it becomes a taller version. The first one is supposed to be a curve. The second piece is more of a straight line. And what has to be done last?
Yeah.
Yeah. The f of x subtracting 3 is your last part. We've done everything else. So we're taking our graph down 3, which means every ordered pair just moves down 3. Okay. Let's see. I did have a point at negative 3, 0. If I move that down 3, where am I at? Negative 3, negative 3. I did have a point at negative 1, 4. Where is that? Negative 1, 1. I did have a point at 3, 0. Where is down 3 from that? 3, negative 3. It should look the same size as the last one, just shifted down. Okay. Page 131. 2 through 32 evens is what you're looking at. Gosh darn it. Oh, man. This is a bad one to have messed up. Do I have to move it? Move my page down a little? Well... And let's see, almost there. Nope. Good enough. Okay. Okay, we're just gonna go with it. Page 131, 2 through 32 evens. Good enough.